Almost all data scientists use SQL for exploration and analysis. SQL looks very simple and has a certain degree of interactivity, and using it for data exploration and analysis seems very good. However, when the situation becomes complex, the complexity of SQL code will increase sharply, making it not simple anymore. For example, the longest consecutive rising days of a stock, the stock price increase for the top 3 days, funnel analysis of e-commerce user behavior data. All of these examples, without exception, use multiple layers of nested subqueries. Some are difficult even if not very long, while others are long and difficult. There are many similar calculations. These complex requirements typically require a multi-step process and involve order-related operations, requiring a very convoluted detour measure to be solved using SQL, resulting in hundreds of lines of code and multiple nested layers. The lives of data scientists are consumed in SQL writing. Moreover, SQL debugging is also very cumbersome. SQL does not provide breakpoints and step-in, which are common debugging methods in most languages. It can only be disassembled and gradually debugged. When SQL is relatively short, this isn't a big problem. But as mentioned earlier, the SQL statements are often very long and has multiple layers of nesting, making it very difficult to disassemble them. The lives of data scientists are consumed in SQL debugging. Complex SQL often cannot run fast. The performance of SQL mainly relies on the database optimizer, which can only handle simple SQL. For example, when selecting the top 10 from 100 million pieces of data, the optimizer will not directly perform a sorting by literal meaning, but will choose a more efficient method. But when the requirements are a bit more complex, such as changing the calculation requirements to find the top 10 within each group, the increase in complexity is not significant, but it has already made most optimizers dizzy, resulting in only literal sorting and a sharp decline in performance. The problems encountered by data scientists are far more complex than this, such as e-commerce funnel analysis. Writing SQL is very complex. Optimizers can only be more dizzy and slow, and in big data scenarios, it can even take several hours to a day. The lives of data scientists are consumed in waiting for SQL execution. The database cannot directly calculate external data, and the data must be imported into the database beforehand. The data source is likely to be text, Excel, web crawlers, etc., which must be cleaned according to certain norms in order to be correctly imported. Databases have strong constraints on data, and there are usually significant differences in the type, format, and granularity of data before and after importing into database. The cleaning process is often cumbersome and time-consuming. The lives of data scientists are consumed in the trivialities of SQL. SQL has various setbacks, and data scientists will also seek other tools, such as Python. Python is superior to SQL in many aspects, including ease of debugging, procedural computation, openness, etc. However, Python also has flaws. The third-party library Pandas in Python has a rich set of calculation functions, and some calculations are simpler to write than SQL. But when the situation is complex, the code is still difficult to write. For example, the stock price increase for the top 3 days. Python cannot directly reference adjacent members and requires Shift to perform alignment, which can be slightly cumbersome. For another example, the longest consecutive rising days of a stock. This more complex task can only be hard-coded using a for loop. Python has many IDEs and also provides debugging functions such as breakpoints, which is much better than SQL, and there is no need to disassemble the code. However, checking the intermediate values still relies mainly on the print method, and it needs to be deleted after debugging, which is very troublesome. Python provides little ability to perform big data operations. The Pandas library can directly perform in-memory calculations, such as sorting, filtering, grouping, and aggregation. However, these functions cannot directly handle large data that exceeds memory, and require hard coding to segmentation, making the code much more complex. Sometimes, specialized algorithms such as hash group is needed for performance reasons, making the code even more difficult to write. Parallelism in Python is fake. To utilize multiple CPUs, complex multiprocesses parallelism is required, which is beyond the capabilities of most data scientists. Unable to write parallel code, can only run slowly in series. SQL is no good, and Python is also not good. Who can save the lives of data scientists? Spark SPL, a tool specifically designed for structured data processing. SPL is the formal language of Spark, which is concise and easy to understand, convenient for debugging, and supports big data and high performance, fundamentally solving many shortcomings of SQL and Python. The SPL code is more concise, which can greatly reduce the coding difficulty of complex calculations and save a lot of programming time. Previously mentioned the difficulty of writing using SQL and Python, the stock price increase for the top 3 days. SPL provides more professional ordered calculations, and the code is easy to write. The longest consecutive rising days of a stock. SPL appears simpler, and does not require an explicit for loop. E-commerce funnel analysis. SPL is also more concise, in line with natural thinking, and this code can handle any step of funnel, while SQL code needs to write more sub-queries when facing more step funnels. This is because SPL has a deeper understanding of data processing and computation, providing more powerful data objects and operations. SPL supports complete debugging functions, including setting breakpoints, step in, skipping, and other functions. During debugging, intermediate calculation results can be directly displayed in a table format. SPL also has auxiliary debugging functions such as variable monitoring and exception checking. The debugging convenience of SPL is significantly better than SQL, and it is also much more convenient than Python's print method. For large data that exceeds memory, SPL provides cursor methods to access external storage data. SPL has elaborately designed external storage calculations, and the code for both inside and outside memory calculations is almost identical. SPL supports thread-based parallel computing, which can fully utilize CPU multi-cores. Parallel computing only requires adding one option. SPL makes it easy to write code with low computational complexity and runs faster. For example, in the top-N problem mentioned earlier, SPL understands top-N as aggregate computation, and the computational logic does not require big sorting, which is much faster. Moreover, the top-N within groups and the top-N of entire set are written in the same way. There are many high-performance algorithms provided by SPL, and the ones marked with asterisks here are original algorithms created by SPL. SPL naturally has openness, and can directly calculate various data sources, such as CSV, Excel and other data files, as well as various relational and non-relational databases. It can also handle multi-layer structured data such as JSON and XML. No need for data importing, saving time for data cleaning. SPL also provides its own format files, overcoming the drawbacks of low speed and ambiguity of text files, while also having the portability of files. As a comparison, Python lacks its own storage solution. Relying on text files is too slow and ambiguous, while using a database loses portability. SPL also has good enterprise attributes. After data scientists have finished exploration and analysis, the results may be integrated into enterprise applications. SPL provides friendly interfaces and standardized version control, seamless and authentic integration, and worry-free migration and upgrading. On the contrary, Python code is difficult to integrate into Java applications, and the versions are chaotic and lack code compatibility. When integrating into enterprise applications, it is likely to require redevelopment. In conclusion, SPL provides professional syntax for structured data processing, which can describe complex calculations with concise code, has strong debugging interactivity, is easy to write big data and high-performance calculations, provides efficient file storage, excellent openness, and enterprise attributes, saves time in multiple dimensions, saves the lives of data scientists. SPL is currently open source. Welcome to download and try it.